Some hot coffee. Hey YouTube, what's up? I'm Steve, Op Engineer. I'm back working on PAL, my personal automation lab from the last episode. Today I'm installing Magic Mirror onto a Raspberry Pi. For those of you who don't know, Magic Mirror is a software that runs on Linux to display some general information like your time, calendar, current weather, forecasted weather, and any other custom modules like news and stuff like that you want. And then Raspberry Pi is a system on a little card like this that's about the size of a credit card, and it's got general purpose input-output pins, and it's great for learning how to use Linux, program, work with embedded electronics, that sort of thing. And so this is the Magic Mirror once it's set up. It's, you know, see my time, current weather forecast, and some news articles down at the bottom. But I would like to add some custom modules to this, and in order to do that, I've realized that it's going to require a lot more knowledge of JavaScript than I recall from college back about 10 years ago. My GERD! And this is a great opportunity to talk about engineering education. So for engineering education, my approach kind of ranges from how much money do I want to put into something, or am I going to be using this as an opportunity to kind of support a living, and then how disciplined or undisciplined is it. In general, consuming is just going to be, if you're consuming entertainment, goods and services, you're going to be spending money on it and time, and it's not going to be very productive for yourself or anybody else. And then you can look at something on the hobby spectrum as maybe it's productive, like creating a Magic Mirror where it consolidates all that information that you would otherwise be searching on YouTube or whatever, Googling, and displays it. But it's a little bit of a cost. And then you get into look at certified work, things that industry expects you to have, like a mechanic might be certified, electrician, plumber. A lot of the trades tend to be industry certificates where the certificate shows that the person has the required knowledge to perform the task, but having that certificate may not necessarily be a requirement to perform that task. It's not like a public health concern where if you fail to perform a job a certain way or fail to have a certain background knowledge, then you're putting other people's well-being at risk. And so that's why for education, the license practices are very controlled education. I mean, you can learn anything you want on the internet nowadays with MIT, Stanford, and all these awesome colleges posting their stuff online for free. But ensuring that you know it is very important to any employer. So that's why they're going to expect some sort of a credential or certificate or accreditation for the education that you've earned. So that gets into the different types of education. Self-guided education is like what I was saying, with just doing your own research, following tutorials, and maybe trial and error if it's within your capabilities. But it's a lot of fun, but might not be very productive for supporting a living. And then community guided education can be things like conferences, lunch and learns, meetups to learn something new, maybe getting together and trying out different brewery techniques, that type of thing. Certified education is, like I was saying earlier, a lot of times industry will collaborate to come up with a predefined set of knowledge to teach individuals how to do something. A lot of the trades, again, are how to replace certain parts on different types of vehicles. And then accredited work is the most common thing you hear about nowadays. Everybody goes into college once they're done with high school, and the objective being to get into one of those professions that require a fundamental, theory to perform it effectively. And continuing education is just an expectation of pretty much any employer nowadays, because a lot of tasks that are very repetitive are becoming easier and easier to replace or automate, replace with machine or automate. And unless you're working on something that's got a really low supply for automating those tasks and has that job security, it's best to be learning what new technologies are out there to improve your quality or your efficiency of work. Continuing education can be going back and doing anything from that self-taught education, kind of like what I'm doing with JavaScript, to getting additional certificates and going to community conferences to getting an additional or farther degree. Accredited education. So this career track kind of shows the flowchart from once you complete high school. If you can complete high school with calculus and a bunch of AP general education classes, that's awesome. That's going to save you a ton of time and money down the road. But if you don't complete calculus, a lot of high schools are ending with pre-calculus and college level algebra for their senior year curriculum. So that's going to put you into the pre-calculus for your first year. And so I use mathematics as kind of the baseline here, because no matter what discipline you're in, mathematics is kind of the universal language. It's well founded on a set of logic that can be interpreted differently, but it's a prerequisite for the majority of technical fields that you'll get into. So after high school, if you start in pre-calculus, that really kind of sets up your timeline for mathematics. You have to take pre-calculus before Calc 1, Calc 1 before Calc 2, Calc 2 before Calc 3, and so forth. And a lot of the technical classes like chemistry, physics, and certain mechanical engineering, especially electrical engineering classes, will require that mathematics knowledge before you start, or as a prerequisite for that core curriculum. And so you want to start with mathematics right out the gates, and then you can take your general electives early on. But this is going to be things like, your communication and ethics is always important. That's the reason for having general electives. All the others that might not be used in a technical field are still important, but it's just good to get that perspective from different lenses. And then in your later years, that's when you'll get the chance to pick technical electives and kind of focus your core competencies, whether it's mechanical engineering, electrical engineering, chemical engineering, so forth, into a specific field. And after you're done with your 4-year, your bachelor's program, if you want to get into some additional accredited education, there's master's programs and doctoral programs, but really there's 2 tracks for master's. It can be a continuation of your bachelor's, where you just take a bunch of classes and really focus your core competencies in a certain area, or you combine that with a teaching requirement where you become a master and able to teach other students that discipline. And then there's doctoral education, which really is, you are the last hope for humanity in that field.
My mission to bring you to Alderaan has failed. I have placed information vital to the survival of the rebellion into the memory systems of this R2 unit. My father will know how to retrieve it. You must see this droid safely delivered to him on Alderaan. This is our most desperate hour. Help me, Obi-Wan Kenobi. You're my only hope.
Humanity is going to depend on you for that theory, whatever it is that you choose. All right, when it comes to engineering education as a profession, you're going to start your career path with your core competencies, all your general education electives, things that are reading, writing, and arithmetic, and helping build out your ethical and communications abilities. And this is something that you'll continue to work on throughout your career, but it sets up the core for your engineering competencies. Engineering competencies are going to specialize you in a certain field of engineering, whether it's like electrical engineering, civil engineering, mechanical engineering, chemical engineering. Those are the core areas, and there's other specialties that branch out from even that. But once you're done with your core education, you have the theory that you need, but none of the experience that you need to really be a licensed professional in those areas. After you're done with your degree program, you'll get out into the field and you'll be set with a theory that you need to pretty much understand anything down to its most fundamental level, but you won't have any of the know-how of why things are done the way they're done. I mean, a lot of these professions are set up on hundreds of years of standards and ways of doing things that may not make sense at first, but require that experience and knowledge of the background by working in it for a little bit to really make yourself a professional. And after a few years, if your branch of engineering requires a professional engineering license, you can go out and the state and the NCEES will put together a curriculum and a test that tests you on your professional engineering knowledge and background experience. If they approve and you pass their examination, then you can get licensed in one of those professional competencies. And from there, you're going to be required to continue maintaining that knowledge, whether it's power and energy, HVAC, control systems, petroleum engineering. These are areas that are constantly undergoing change and require professionals to maintain their education and understand the latest theory that's being developed and driving changes in that industry. So that's kind of the summary of engineering education, and sort of went off on a tangent from my magic mirror there, but it was related to me going back and understanding what I didn't know before and trying to set up a educational plan or a lesson plan for myself in JavaScript. And that about wraps up my 2 cents on engineering education. Please like, subscribe, and comment below. If you have any questions, please post them. I'll always reply, but make sure you keep it family friendly, and I'll see you next time.